Recent findings have revealed significant vulnerabilities in AI inference frameworks from major tech companies like Meta, Nvidia, and Microsoft. This matters because these flaws could allow attackers to execute arbitrary code, potentially compromising sensitive AI infrastructures. On November 14, 2025, researchers from Oligo Security reported that critical remote code execution vulnerabilities are rooted in the unsafe use of ZeroMQ and Python's pickle deserialization. The main issue originated from Meta's Llama framework and has since propagated to various other projects through code reuse, raising concerns across the AI community. In this video, we'll explore the details of these vulnerabilities, their implications for AI security, and what steps can be taken to mitigate the risks. If you found this update helpful, please like, share, and subscribe to InfoSec Now for the latest cybersecurity news. Your support really helps us continue building useful content for cybersecurity professionals. The vulnerabilities identified in AI inference frameworks highlight a concerning trend in software development practices, particularly the risks associated with code reuse. The phenomenon known as ShadowMQ has emerged as a critical issue, where insecure deserialization practices have proliferated across multiple frameworks due to the practice of copying code without adequate scrutiny. This pattern not only affects the original code base but also propagates vulnerabilities into other projects, demonstrating a systemic risk in the AI development ecosystem. Oligo Security's findings indicate that this issue is not isolated to one framework but is a widespread problem affecting several major players in the industry. The fact that different teams, working independently, have replicated the same unsafe coding patterns raises questions about industry standards and the need for more rigorous security protocols during the development process. The shared reliance on components like ZeroMQ and Python's pickle module, without proper security considerations, underscores the urgency for developers to prioritize secure coding practices. Moreover, the implications of these vulnerabilities extend far beyond theoretical risks. The potential for attackers to execute arbitrary code within compromised AI infrastructures could lead to severe consequences, including unauthorized access to sensitive data, privilege escalation, and even the deployment of malicious software such as cryptocurrency miners. As AI systems become increasingly integral to various sectors, the stakes of these vulnerabilities rise correspondingly. The ongoing challenges in patching these vulnerabilities, particularly in frameworks like Sarthi-Serve and Shadowlang, illustrate the complexities involved in software maintenance and security. Incomplete fixes or delayed responses to vulnerabilities can leave systems exposed, emphasizing the need for continuous monitoring and rapid response capabilities in cybersecurity practices. In light of these developments, it is essential for organizations to not only address existing vulnerabilities but also to foster a culture of security awareness among developers. This includes implementing thorough code reviews, encouraging the adoption of secure coding practices, and investing in training to help teams recognize and mitigate potential security threats before they can be exploited. The lessons learned from these incidents may serve as a catalyst for reforming how AI frameworks are developed and maintained, ultimately leading to a more secure technological landscape. The recent vulnerabilities in major AI inference frameworks underscore a critical need for heightened security protocols across the industry. With the discovery of the ShadowMQ pattern, the implications extend beyond individual frameworks, revealing systemic issues in code reuse practices. This pattern, where developers inadvertently replicate unsafe code across different projects, highlights a significant risk in a landscape where collaboration and rapid development are prioritized. The vulnerabilities identified in frameworks like Nvidia's TensorRT-LLM and Meta's Llama not only pose immediate threats to the integrity of AI systems but also represent a larger trend where the speed of innovation may compromise security. As these frameworks serve as foundational components for various applications, a successful exploit could allow attackers to infiltrate entire AI clusters, leading to model theft or the deployment of malicious software. Moreover, the interconnected nature of these systems means that one compromised node can have cascading effects, potentially affecting numerous applications and services that rely on these AI engines. The severity of the CVSS scores assigned to these vulnerabilities, some nearing critical thresholds, indicates the urgent need for robust patching and security assessments. In light of these findings, organizations must prioritize security audits and implement stricter guidelines for code reuse. This includes rigorous vetting processes for third-party code and fostering a culture of security awareness among developers. As the AI landscape continues to evolve, the responsibility lies with both developers and companies to ensure that innovation does not come at the expense of security. As the landscape of AI technology continues to evolve, addressing the vulnerabilities uncovered in major inference frameworks is critical for maintaining user trust and security. With the root cause identified as unsafe code reuse practices, particularly involving ZeroMQ and Python's pickle deserialization, it becomes imperative for developers to implement robust coding standards and security audits to prevent similar issues from arising in the future. In light of these vulnerabilities, organizations must prioritize the establishment of security protocols that include regular code reviews and vulnerability assessments. This can help identify and remediate unsafe code patterns before they are propagated across multiple projects. The emphasis on secure coding practices is not just a technical necessity. It is a responsibility that developers share to protect users and sensitive data from potential exploitation. Users also play a vital role in safeguarding their environments. By disabling auto-run features in their integrated development environments (IDEs) and being diligent about the extensions they install, users can significantly mitigate risks. It is crucial for them to ensure that any Model Context Protocol (MCP) servers are sourced from trusted developers and repositories, thereby reducing the likelihood of malicious code being executed on their systems. Furthermore, utilizing API keys with minimal permissions can limit the potential damage in the event of a breach. Users should regularly audit the source code of MCP servers and be aware of the data and APIs that these servers access. This proactive approach not only protects individual users but also contributes to the overall security posture of the AI ecosystem. As the industry grapples with these vulnerabilities, collaboration among stakeholders, developers, researchers, and users will be essential. Sharing knowledge about security best practices and lessons learned from these incidents can foster a culture of security within the AI community. Ultimately, the goal is to create a resilient framework that can withstand potential threats while continuing to innovate and advance the capabilities of artificial intelligence. If you found this update helpful, please like, share, and subscribe to InfoSec Now for the latest cybersecurity news. Your support really helps us continue building useful content for cybersecurity professionals.